Hello everybody from Romania, from your favorite artist electronist, Mr. Q12 here. Alright, so as you can see, I made some modifications from the last circuit. Actually, I made a couple of modifications. When you first, the movie before this one, I had only this single 01 code until here. And probably this circuit diagram, because I really don't know what I did. I didn't update it any time, so I didn't save it. I didn't. Probably this was the circuit that I had for that code, for this code here. And also, as you can see, I'm not sure the last time I did. The last movie I did, it was C, where I was starting D, and I made another three of D, DA, DB, and DC. Right now I am on DC, this little last file. You see it here in the title there. And also this guy here, where the fuck, yeah, 03.c is the last, big C is the last file that I'm having here, this .c, you see, 03.c file. The rest is just some stuff that is making from the program, doesn't matter. We are actually catching this hex file that is creating it after the compilation, or after I'm building the program, is creating this hex file, and this file is picking up by my settings that I made already here. You see, so for this pick is loading pretty much that hex file from here, and or whatever I'm giving it to load. But for this test, I need exactly to have the code and then to test it in Proteus. And I'm working like this from a very long time actually. And yeah, I made it work. I managed to make all the digits work. I will show you right now how it's working, and then I will get back to a little bit of history. As you can see, my random something memory, read-only memory, random access memory is 40%, so I don't have too many variables. This is what is showing here, 40%. But read-only memory, it means the program itself, and it's occupying 87%. And I could lower it to 75 or something before I put this line here for every digit, excepting the one, because this is the resting point, and it's turning back to this one pretty much. When this deck is 0, this variable deck is 0, is incremented once, and then it's jumping directly into this digit 1. So it's starting with digit 1 all the time instead of digit 0. Digit 0 is actually the last one. I know it's a bit inverse from the normal. I can easily make it correct to start from 0 and then increment until 9, but that's nuance, you know, it's a flavor, and my flavor right now is with the 0 at the end and starting with 1 for the moment. If I will see in the future that this is a problem, it's very easy fix to do. It's very, very easy. So this line here, so this is the reset button. It's the last thing I added to this entire circuit and to the program itself. This is absolutely the last thing, and I couldn't find its place for a very long time, and then when I find it finally, it is occupying a little bit more space from read-only memory here. Before, without it, it was like 75%. So it up like almost 10%. It's up. Only this fucking line that is repeating 9 times, not 10 times, but 9 times. All right, enough about reset. Let me show you how everything is working. So pretty much this is is already built, is already working, but I'm showing you anyway. You know, I'm building it. I'm waiting for this motherfucker to get off, to turn off, and then I'm playing here. I'm pushing that play button, and you will see B and C. It means number 1. When I'm clocking once here, it's switching to number 2. As you can see, when I'm clocking another time, it's number 3. And clocking, yeah, it's a problem with the clock. I will explain later. So this is number 4. You see, B and C, G and F. When I'm clocking again, 5. This is 5 like this. You see, and now 6. Yeah, you see, 6 is doing like this without B, excepting B, and is rolling like that. It's rolling like that. 6, 7. This is 7. This top one and this line here. 8. 8 is very nice. Pack. So it's pack, and then like that. It's starting from C probably. Let's actually see. Yeah, it's starting from segment C. Is going into G and then F, A, B. That's number 8. And 9. Starting from G. I can actually show you. It's starting from G, F, A, B. You see, F, A, B, C, and D. C and D is the last part. And now 0. 0 is all around. It's starting from A and reaching F, and then it's starting again. And when I'm clocking again, it's doing some funny business and is getting back to 1. So it's clocking like that. And when I'm let's say I'm on number 3 here, and when I'm pressing reset, resetting to number 1. This is this line that is doing this reset thing. This is very optionally. I really didn't think of it to add it. I added it in the last minute, if I can say so. Actually, it took me hours to insert it, but it was the last decision. I thought it's a nice thing to add. And of course, if I'm pressing reset here and 1 is not doing anything, I have to get inside one number at least 1 time greater than number 1. So number 2, I'm resetting back to. So it's working, is what I'm saying. I highly reduced the number of pins. As you can see, it's only having 2 inputs, this clock and this very optional reset. You can have it, or you don't really need it. You can clock it very fast and reach whatever number you want. Only 2 outputs. Output data, which is this line here. This is where it's sending the digits, I believe, segments, all the segments, the combinations between the segments, all of the stuff, and the combinations pretty much. These combinations that you're seeing here are like this: segment A, B, B, C, blah, blah, blah. And then it's doing the funky business. I escaped from this enable thing. I don't really need it. So this block that you're seeing here, I can get rid of it and connect directly to here, to these guys. So all these inputs from here is going directly on the bases if these are NPN transistors and not buffers like I'm having it right now, because it's a program problem. It's a problem with the program. And I cannot do what I want to do with NPNs, with normal transistors. So I'm forced to use this buffer gates that I'm having there. So if you link this wire instead of here directly on this other wire, so this wire with this wire directly, and making abstraction on this, everything will work. This is what I will do in reality. For sure. So the chocolate, it is greatly optimized. Also the code is very optimized. The history of the code, let me show you the main code. So this is the main code. So setup counters. This is for the PIC microcontroller. It's a setup. And then these are my setup pins. Everything to reset to 0 when it's starting everything. And then this is a while that is functioning forever. Pretty much everything is repeating inside this while, and it's from there to here. That's it. It's that long, this while. And inside here, what is doing? It's cleaning all bits to 0, exactly like here, but from a method somewhere. Is dealing with some variables that are very important. Adding this is a very tricky. I spent like 2 or 3 hours until I figured out this motherfucker. Before this, I couldn't actually make the click, the clock click. So it was jumping very fast to, it was incrementing extremely fast to 10 pretty much, to the last digit, and it was giving me the signal. I have a signal pin that is helping me. It's on pin B1, so it's GP1 here, is lighting up one pin for half of a second, just a blip. And I know I finished the counting pretty much, and it helped me a ton. It helped me very much while debugging and seeing what the fuck. Siren is hearing outside when I'm filming. So what the fuck is going on inside the chip, and where I reach with the incrementing pretty much. So this was a very genius piece of code that I implemented, and also all this stuff. Like I said, everything that you see out there outside main was here inside this while loop. So in the last minute, I transformed all the code that I had here. Well, the essential code, not every digit. Only digit 1. I was working on digit 1, probably digit 2 as well. Also the segments, segment A and B, and then I transformed them immediately into this outside function. And I call it from inside this loop while I was working. So if I was after I finished the segment, I was starting working on the digit, and I was calling these segments, you see, but not from outside, from here where we are right now, but inside from here, from the while loop. And after I finished the logic of the digits, I transform them into outside functions like you are seeing right now. You see, they are outside, and they are called, so all these digits are called inside this while loop. So everything that the history of the program, or the evolution of the program, was all the time inside this while loop. This is how I'm doing stuff, my coding all the time. I'm not really used with working with something externally like this to reference to it. It's a very confusing for me, at least. So I'm keeping it all together to see it all at once, and to work with my eyes through all the lines and verifying everything. And after I find the logic that I need, and that is the correct logic that I really needed, then I transform it. It's like packaging. You make a package, a little package, and this little package is called a method, and you put it outside of your main, and you just only reference to it, and it's also helping the code, the read-only memory in this case, the code to be very thin, not to be too much stuff to have. You just only reference to it, especially if it's repeating code. Like my thing that I had here, and I couldn't repeat it on digit on. So this guy here, I couldn't. I really tried to make it in an outside and only reference to it, because from 75 it was going up to 78 maybe, or maybe 80% or something. If it was an outside function like these packages, like these little functions are. So I couldn't make it an outside function, because this break, it must be contained inside this loop. If it's outside the loop, it is in an outside package, like this package, this break will not actually be understood by the while. So the while function, if it's seeing break inside it, it will work. But if the break is outside, external function, it doesn't really like it, and that's a pity. That's a shame. It could have saved a lot of space. But other than that like 10%, it eated only one single line of code. But remember, before I couldn't even get to number digit 2 to display it. I only got to digit 1 to be able to display it, and now I have everything. And I had to drastically change the code. I recoded everything from scratch, from 0 again. When I started the code, in the first movie, I went like this, and I was like this on this path, And then I said to myself, I will start it again, and I already had the direction. And then I branched. I didn't went the same direction with the other one. I kind of branched like this, kind of like this. This is so this is 1, this is 2. And the third code, actually, I use quite a lot of this from this number 2, and I kind of branched like this from it. So this is the third code, and the best one actually. And this should have been a bit more straight than the too much curved ones. So I hope it makes sense. But pretty much I had to start to cut everything out and start again, and that's what I wanted to show you, to tell you. So I throw away pretty much. No, I didn't throw away, but I made a new file, absolutely blank file, and I started to code. And I really didn't know how it should have been. Let me actually open. Let's see. I believe this is Q. Then this is blue probably. So let me open this guy here. Probably. I had to do, you see, I have two wires instead of one. So I have to clock, I have to input and then to clock it. This is a bit more complicated program that I originally, it's immediate, the immediate program that I was thinking to make. So it's before this gorgeous, circuit and code that I'm having here, very simplistic and very easy to work with and very easy to understand. Before this, I had to actually make it extremely complicated, but also it worked like this as well. And then I thought to simplify it further. So I jumped and I modified pretty much the code that was running this PIC here. I modified like you see it here, and also I modified the circuit and I adapted everything. And it took me like 1 day. I want to be proud. It took me quite less time than previous. But for this number 2 code, it took me another day. So in total, number 3 in 1 day, number 2 in another day, or 2 days maybe. So probably 2 or 3 days, these 2 codes, and also the circuits that was following them. So this is for number 2, and this is for right now, number 3 that I'm having the reset. And before I had to click and input whatever I clocked, not click, clocked. Let me actually show you how they are working. Let me close. Okay, so now I open this number 2. So we are one step back. Actually, this is the immediate step after the last movie that I made. The last movie, I made this program and this circuit diagram that you are seeing here. And this is very, very different from what you've seen. I will only briefly get through it. It's having the same bits, as you can see, the same segments probably, or a little bit different. I believe I used another logic here. It's tiny bit, but it was very, very important. But it worked. As you can see, it's looking very similar with the other code, but this was a bit more funky. So let me play it for you. When I'm playing it, nothing shows nothing shows up because I have to actually input how many times? 10 times. So greater than 9. 10. I have to click here 10 times. So, but also I have to input a code made from decimal numbers. So if I'm clicking once and clock once and then switch it back to 0 and then 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 10 actually. It created number 1 here. Now let's make number 3. So I'm switching the input high. Everything is stopping, but it will reset to 0 immediately on the next clock. So now when I'm clocking 1, 2, 3, I said, number 3. Now I'm taking off the input, put it to 0. So 3. Now 4, 5, 6, 7, 8, 9, 10. And it is indeed number 3, you see it? So that's. Now let's say number 9, because this was a tricky one, number 9. So now I'm setting it high. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I have to bring it down because if I'm lifting it on high, it'll count as 0. So it's not good. I really must have a 0 there. And now 1. And it is number 9, you see? No. So I made a mistake of counting with that positive all the time. After I reached 10, it got me nothing. And I was wondering, why the fuck? And so I make this attention. Number 9 must be made from 9 positive clocks and 1 negative clock. You see here on the last line. So this is how this special and 0 actually is very easy to make. I have to probably to clock like that once to stop everything. And when I'm clocking like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is 0. I didn't put high anything here. I only put high to reset the last bit that it was, but I didn't clock it. So I only make it on off, but leave it on negative, and clocked only the negative bits pretty much. It's a bit funky to drive, but it is possible. And I was thinking to actually use a 4017 counter. And when I started to think about it to start to make the circuit, then I got the bright idea. Wait a fucking minute. Maybe I can transform this PIC microcontroller 12F508, which is my favorite PIC, to transform it into a simple counter. So I kind of took this counter as a reference and transformed my ensembler, everything that I have here, into a counter like that. That's all that I did. And the reset pin as well. It is having an enable, which I don't really need. That enable I can make it from positive and negative when I'm powering the chip. I can enable the chip or not by putting power on it or not. And this is it. The code is depending on this clock, I believe, and it's using more variables. And when I'm building it, let me make some text. So it's having 44% variables, 77, a little bit smaller than the other one, and it is working absolutely fine. But I don't like the mechanism, especially the input mechanism that is here. It's it's not good. But it was like this simply because I didn't know how to make it. So I pretty much had to do the hard stuff first, and then get to the conclusion to simplify what I was already had here. So this is the history of the project. So I worked 1 or 2 days on this, and it was very, very hard. And I managed to make it. Theoretically, here in Proteus. If it's working here in Proteus, theoretically it should work in reality. But I will not say jump yet. I will not say. I have to actually test it and actually see how everything is working. Oh, in this circuit, I didn't like this circuit diagram that I'm having here because it is pretty much using all the pins of the chip. You see, 5 pins, and only one I left it for testing for signal. I have a pin for signal here to actually telling me when is finished counting, when it's back to 0, when it's starting to count to plus 1 there. So that's it. This is this pin is doing is I actually used all its pins. This is the history. Okay, I believe I finished telling everything that I wanted to tell. To get back to where we started. So this is this is the new. So this is the latest and the greatest, and also it's code here. So I will scroll down for you to see the code very slowly. So this is segment A. Let's see. So A, this is D, and this is F, G, digit 1, digit 3, digit 5. This is the code. This is 7. This is the code. Digit 9. This is the code and everything. Digit 0 is a little bit here on the main, and fucking police. So the main here and a little bit here, and this is it. This is all the code. I wanted to show you the code. In the future, if you want to do something similar, to take a PIC, copy the stuff that I'm having here, and use it at your discretion. It is my work indeed, but I really don't care, because I did to learn everything that I know. I had to use other people codes, so it's but not right here. I'm saying in general, you know. All right. So this is it. I managed to make this working with all the digits, inside, and in efficient enough to fill up responsibly the memory, the read-only memory that is having inside. And yeah, I'm very pleased. Right now, I am pleased. I said that I have a little bit of funky problem. This delay here, it gave me a lot of problems, and I mean, until I figured out that it needed this delay. So this delay is, I will read what is written there. Give time after pressed clock button to get to 0 state. So pretty much, if I'm pressing to this clock to positive, if I'm pressing too fast, you see, it's not switching. Let me reset it. Also, okay. So that's the one. So if I'm clicking very fast, sometimes it's getting the 2. But if I want to get into 3, yeah, now it gets into 3 because I kind of there. So if I'm doing that, it did catch it, but not all the time. So if I'm pressing right now, it's still on 2. If I'm pressing right now, it's still on 2. If I'm pressing longer, it will switch to 3. You see? So while input pin is negative, so while this is 0, this clock pin is negative 0, like it is here. Do this stuff inside, okay? But if I'm bringing it to positive like this, it doesn't. It is switching extremely fast. This is what it's doing, and switching very fast is incrementing this this variable extremely quickly. Is reaching 10. And it's showing some random number. So pretty much, if I'm holding it as high right now like that, it will, when I'm pressing it as 0, yeah, this time it got to 1. But if I'm doing like that, you see, this is absolutely 3 is number 3. Why is doing that? Because I have this delay, and because of this delay, it's kind of delaying a little bit when switching between the incrementing. So it's really, as long as I'm keeping the button high, it is incrementing second by second, half of the second, you know, it's delaying. It's incrementing up, a little bit slower, you know, but it is doing it as long as I'm keeping the button high. So this depends how long you press the clock button. This is summarizing very well what I'm having here. It is a little bit of problem because I have to adapt perfectly the mechanism of clocking. So the clock that I'm having, that is coming from outside, it has to be a certain frequency, you know, a certain delay, and also I must adapt the code that I'm having here to the speed of the clock that is coming from outside. So that's a problem. That's a very big problem, especially if I'm having a potentiometer with variable speed for the clock. You know, to clock back, or you know, very fast or very slowly. So it is kind of a static option that I'm having. It is very static option. It's not a variable option that I'm having. This clocking is not variable. It's pretty static. I have to specifically change the code in accordance to the clock input that I'm having from the device. I have to know exactly what speed the clock that I'm putting there is, and then modify the code here, or adapt to the code that I'm having here to adapt the clock that I'm having it from external source. I will see how it will actually work in reality. I have no idea, and I hope it will not be such a big problem, because right now, as you can see, it is running very slowly right now. You can actually see them moving around. If I'm moving them too fast, it will not lit up the segment, unfortunately. So this is barely at the best behavior of them, you know, the maximum best behavior. If I'm changing to higher frequency, it will crap itself. If it's too slow, you'll have to wait pretty much. It will not shape a number here pretty well. I hope in reality it will be another story. I really hope. I hope what we are seeing here are milliseconds, and those milliseconds in reality will be fast enough for the human eye to not really give a shit, you know, to actually see a number correctly displayed. I really hope so. If not, then all this project goes to drain. But it was a very interesting project and very educative. I really learned something. Well, I learned my C compiler here that I'm having. I really didn't want to get into the ensembler mess. I'm not that good there. I am good, but not that good. And I really try to avoid it. Maybe it's a good idea to actually do all this stuff in ensembler. I don't know, but it was very complicated here in C compiler. And I don't think I have any chance to make it in ensembler directly. Although I have an option though. I have this awesome. Yeah, this is it. This is it. Yeah. So it is creating an ensembler compilation, you know, and it is automatic. Very interesting. It's very interesting, and you can learn from all of this, and you know, try to stay on this code and learn from it, because it is functional in my C language. It's also having this, you know, commenting the code that is is here pretty much. Is the equivalent of this probably. All this is equivalent. Yeah, and output this is, it means this in ensembler, and here is the code in a higher language, in C language. So that's I'm not sure what the fuck he did here. Probably, I don't know. Is this a pointer? Huh, I have no idea. Yeah. But it is creating this file as well. It's called list or list. It's listing the ensembler code pretty much, and it's pretty big. And it's very important to have it to actually trace back to your code. You know, you can make two similar codes here in C compiler. And then if you are working in ensembler to actually compare this listing file with your code and auto-generated, and compare the auto-generated code that this guy is doing, and kind of correct yourself there. Well, it's complicated. It's very complicated, and I really don't have time anymore. I mean, doing it in C compiler, it's a bit more easier. It's a bit more humanly acceptable. Ensembler is too hard, at least for the moment. No, for me. This is all that I wanted to show you and present to you. So in the end, this project is made, and very elegantly, I may say, extremely elegantly. I really like it. I really like the clocking, one single clock, and the iterating from one character to other. Very cool. I really like it. And I want to test it in reality soon enough, and see if it's actually doing the thing that I'm testing it here in this simulator. I hope it will be the same result as in the simulator. If not, holy fuck, what a waste of time. But it's a teaching moment, I suppose. It's a lesson. It's a very hard lesson. But you know what? I really thought I will make it. I had this feeling and this idea that I will make it work, and I did. I also stayed day and night, from the morning until the night, pretty much the entire day, in my chair and just coding, paying attention to every single, changing the codes, a lot of changing, a ton of changing it was. To reach this level of coding that I'm having right now, I changed the shit out of, I have no idea how many changes I made. Very draconic changes, very drastic, very to the bone, cut to the bone and back and take it from zero again and again and again until it worked, until I get the result, some spark of resulting. And after I get those results, those sparks of results, it is possible. So I push it further and further until I reach this level that I am right now, which is not really the best one, because the only problem that I have is with this motherfucker clock that I'm having here, and I really don't like it. It's the only problem, biggest problem actually. It's a big problem. I really want passive clock. This is more like an active clock. It's depending on this value that it's having there, and I don't like it. A passive clock will not care how long or how short you'll hold the high or low level. That's a passive clock, and I really wished I had one. Like this reset, it doesn't care how long you press it or how short. Actually, it is having a little time delay of how short. So until it's finishing all this code here, and then it's reaching this line, then it's resetting. But it's very fast. It's less than probably 10 milliseconds. It's very fast, this guy. But I wished, and it's kind of passive. It's kind of a passive button here, input. But this is quite active, and I have to change both here in the code and in reality. I have to pay attention what I'm putting there, to not to be too fast, not to be slow, to actually give me to calibrate the clock to give me the good result that I want here. So it's not so cool, but it is cool in general. If I'm not giving myself a 10, I will give myself a 9. So it is a 9 grade, this project that I'm having here, and I am very proud. I really wish to actually put it in reality and test it. And keep in mind, this is only for one single character, one single digit, but I have 3 digits here. So 3 PIC microcontrollers, 3 8-bit shift registers, and this block will not be necessary, but this block, yes. So 6 transistors and only 2 gates. So I can use one single chip with 4 gates for 2 digits. So 2 4030 chips, XOR gates, chips, to use 6. So 2 times 3 digits equals 6 gates, pretty much. And they have in total 8 gates. So yeah, 1.5 chip I will use for the XOR. It's not that much, I believe. But it is quite a large circuit for only displaying this motherfucker here. They are tiny. They are very small displays, and this is quite a big circuit. If lucky me, the PIC12F508 that I have the SMD version as well. I have the DIP8 version also, but also the SMD version. But I don't have this 8-bit shift register. I don't have it in a SMD version. If I was having it in SMD, it was truly small circuit. Also the transistors here, I have SMD ones, and also the XOR gate. Actually, I have individual XOR gates now. I remember this 7486 with only 5 pins, positive, negative, 2 inputs and 1 output, 5 pins per gate, and I can use those instead of a single package. And those are SMDs, so I can make quite a small circuit footprint, pretty much, exception this 7416, which will be the largest, most probably. I'm not sure if I will actually add all these LEDs on the outputs. I will see. But so far so good. I'm really proud of the progress that I did so far. I hope you like it. I hope you learn something with me, that it is possible if you push, and if you stay, and if you push it harder, and if you really want it, because I really want it myself. All right. This is it from Romania, from our favorite artist electronics, Mr. Q12. See you later when I will actually implement it in reality. And also, let's talk a little bit about capitalism, because we are living it. And in capitalism, you cannot do absolutely any money on what you really like to do and what you really want to do. So if you like something and you really are good on something to make it, you are not allowed, or is not possible in capitalism. Capitalism is very good to be stupid and to make the lower work possible, because that's your place. But really, the stuff that is, well, I'm not sure how high it is, but fun stuff like this. For me, it is fun. I'm doing it from. I am an artist. And I'm doing it as a hobby and a pleasure. And coding is a pleasure for me. It always was. I fall in love for a very long time for coding, and I really wanted to know it well. I kind of get it. I'm not the best, but I'm good enough. When I'm saying I'm good enough, I'm getting the results that I want them to get. So if I'm putting something in my head, I will get it. Slower or faster, doesn't matter the time. Only it matters the result, and this is it. But in capitalism, you cannot do such things. This is my teaching. Is what I want to understand, and to do not hope. If you are hoping, if you are having hope on something, it will greatly disappointing you, and you will have a lot of trauma because of that hope. It's like a shock, and you will. You'll get into depression extremely fast. So this is what is good capitalism, the today capitalism that is running, especially in my country, is making you exceptionally depressed about everything, and also stressed. The outside world is money making in capitalism is like the game of stress. If you are good at the game of stress, you can probably succeed. I am not good at it at all. I am very easily stressed, and I don't really like bullshit in any shape or form. But the young people, I was young as well. I did my parts as well. I got some smack on my head from the older guys, and I kind of, I was hoping for the best, and I got nothing. I got shit, only shit. And this is the capitalism for me, and probably it will be for you as well. So put it in perspective. My experience and your future. I really hope you will succeed in your career or whatever, but be aware you are living in capitalism. That is problem. That is very, very extreme problem. And the capitalism, don't confuse it with American capitalism. American capitalism is a beast, very different from the rest of the world. They have a successful, very successful capitalism. It's like Mona Lisa, they make it the best as it can. But the rest of the world is like mud on the wall. That's the perfect analogy. Nothing works, everything is shit, and is not even close to that perfection of American capitalism, because they confuse everything else. It's the same as is happening in their backyard, but in reality, it's not even close. Nah, this is raining with shit instead of water. In this capitalism, at least in these days. All right, I hope you understood my point of view about things. Yeah, I'm very, very upset on this specific, political this political. Actually, it's not political. This is a social living. This is social living. It's not politics. We like to suffer, and because some of us likes to suffer very much, they are imposing the others. They must suffer, and for some money, for a little bit of money, and not for doing what they really like to do. And I am telling, to those who are listening, at least, that it should be done something. It should be to make something about it, to actually make money online, not just lies. Because today's websites that are promoting, they are giving you money, they are actually scamming, and scamming the big time. And if they are big corporations, they are not hiring shit. They are promoting their hiring, but in reality, when you actually go to them and ask, I want to get to your highly corporation, I want to be your employer, and they will not even respond to you, because that's just a mask. It's a surface, and nothing works, especially on internet. I tried many times, and not even close. I didn't get any response. So yes, that's it for this part. I have to bring it to bring in discussion this side of things, because it's also part of my life, which is a bit of suffering, and it's not nice. And although I'm showing that it's possible to do things in hardware and software, in reality, in social, if you want to make something of yourself in reality as a social being, it's and also to make money, it's impossible. It's it's all the doors are closed. Only the chosen ones can get those money. They are bragging with them, and the rest of us are piss in the wind. We get nothing. All right, bye bye for now, and see you later. Bye bye.